Hello, hello, hello. Welcome to my latest live stream. This is live stream number 22. Would you believe that? This is over 40 hours now, probably 44, 46 hours worth of working on this this report. So welcome. Please comment below and let me know where you're watching from. My name's Simon Whiteley. I'm a system safety engineering consultant and accident analysis consultant from the UK. I help predominantly aerospace and defence organisations with their journey, learning about STAMP and then using STPA hazard analysis and cast accident analysis. But I also work in other industries. So I've been working with the European Space Agency, their kind of aerospace and defence, I suppose you could say, but also healthcare, so the Healthcare Services Safety Investigation Branch, amongst others, including railways. So if you're involved in any of those industries, or if you're just curious about what STAMP is all about and how to do it, welcome to my live stream. Please, ask any questions, type in the comments, ask some questions. There is a delay of about a minute, but if you do have some questions, please put them in the chat. And of course, if you'd like to talk to me personally, you're welcome to visit my website. So whiteley-safety.co.uk. And if you want to have a conversation, click this green button here that says I need help now. Stick in your details, send me a message, and we can set up a call and have a conversation. And likewise, in parallel to this this case study we're working on here, I am going to run a live workshop, a Zoom sort of workshop where we get together, talk through the case study, talk through the challenges with STAMP, STPA and CAST, and of course answer any difficult, horrible questions that you might have. So this is a free complimentary event. So if you put your name and email address in there, you can essentially join a waiting list. And once I've finished going through the investigation report, I've completed the live stream series, I will put together a presentation and then I'll send an email out to everybody on the wait list and we can get together and talk about this case study live, personally, on camera, on Zoom, and have a great time doing it. And of course, also, if you would like some foundation training, I do have a one-day one-day online foundation training that's available. So visit my website, click on the pad in the middle, go down the website, choose a date and time that suits you. I will have a new set of UK, European, and US America's time zones. So click those, choose one that's appropriate for you. And of course, once I've launched the new dates, if you join the wait list, I will then let you know when the new dates are announced, which will be very shortly. I just want to get the end of the school term out of the way, into the summer holidays, so I can free up some dates to be able to do this stuff. Fantastic. Okay, so we're going to be talking about the Starliner, and where we got up to last time is we completed, well, in terms of the whole live stream series of live streams, this is number 22. We have got through sections 1 to 5, so the scope of the investigation, additional investigations, the crew commercial program background, the technical root cause analyses and findings, which was a substantial section, section 4, and then section 5, which was the organisational culture and decision-making process during the mission, so organisational aspects, higher levels in the control structure. And so we finished trust yesterday, or Monday should I say, and now we're going to jump into root causes. Now root causes, the section is not that long, it's quite short, so I'm anticipating we'll get through that today. So there it is, it's only 4 pages, so there's only 4 pages of root causes, which is interesting. And then, of course, section 7 is additional observations, and that's 5 pages. And then we've got recommendations, and then we're into the appendices. So if we're lucky, we might be able to get through the majority of that this evening. But if not, I've scheduled another follow-on live stream, but I've moved it from Thursday to Friday. So it's going to be this Friday, 6 p.m, 1800 UTC +1. It was going to be tomorrow, Thursday, but I'm going to be visiting the Farnborough International Air Show. So if you're going to be there, don't forget to say hello. Let's have a conversation. And, let's take some selfies and get them on social media. Let's do a bit of social media influencing. But yeah, so we're going to do section 6 today, root causes. So let's get prepared. Let's get my jigsaw piece. You'll notice this from all of the other live streams. This is one of the core concepts of STAMP, and it's used exclusively throughout STPA and to a significant extent through CAST as well. And if you can burn this into your brain, this is one significant concept that will really help you in how you think about safety and accident analysis. So let's just have a quick check of the comments, see if anybody's commenting. So we've got some viewers. Hello viewers, great to see you. Thank you for coming along. Please comment below, let me know where you're watching from. Everything is a-okay. We've got some audio. Let's just check my audio. Yes, I can hear my voice. Right, we're ready. Here we go. Root causes then. Section 6, root causes. It is important to establish a shared definition of root cause to understand how the Starliner pit team has determined, I'll just highlight them because there might be candidates for inclusion in our control structure model, has determined the root causes presented in this section. The pit team utilised the following definition. Okay, so root cause, an event or condition primarily associated with organisational factors as opposed to technical factors, which existed before the immediate cause and directly resulted in its occurrence, indirectly caused or contributed to the proximate cause and subsequent undesired outcome, and if eliminated or modified, would have prevented the immediate cause from occurring and the undesired outcome. Typically, multiple causes contribute to an undesired outcome. In the absence of a prevalent organisational factor, the root cause may be identified as undetermined. Okay, so I'm going to talk a little bit about that now, because that's quite a specific definition, but it's also quite complex. There's a lot of parts to do with it. So when we talk about an event or a condition, that could be an event or a state of whatever system, subsystem, organisational aspect we're talking about. But in this case, it focuses on organisational factors. So through the lens of STAMP, you could argue, well, is that akin to issues with the control structure itself, as opposed to the controllers themselves, or is it a combination of those two things? Now, when we're talking about causes of accidents in STAMP, what we're always talking about is a definition of hazard, which if I jump over here, I should have it on my screen already. There we go. In STAMP, we're talking about a definition of a hazard, which is a system state or set of conditions. So that's similar. That together with a particular set of worst case environmental conditions will lead to an accident or loss. So it can be a state, it can be a condition, or it can be an event or time limited. But this definition, it causes you to sort of stretch your perspective and think about the topic of, well, what is the system in this case? Are we talking about the spacecraft as a system? Or are we talking about, I suppose you could say, a system of systems? So we've got the spacecraft, we've got the ISS, we've got the organizations, the various stakeholders that are working together to do a space mission. And then, of course, you've got the organizations involved in the design, development, and test and qualification of these technical systems. So we've got a very broad sort of concept to think about. And when we're trying to define a hazard, that is a challenging thing to do. I'm not sort of going to shy away from that. It is a challenging thing to do. But this definition, in its relative sort of clarity, helps you to sort of consider the definition of a hazard in the context of a system state or events. So it really tries to make you think very broadly, but also helps to try and make you more specific, try and be very specific about what we're talking about. And as I say, this is not an easy thing to do. I mean, trying to define hazards, through the various standards such as MIL Standard 882, or if we're talking about civil air transport, Aerospace Recommended Practice 4761, or 4761A is the new version. And then, of course, in UK defence, we've got Defence Standard 00056. So there are various definitions there. And, of course, how those definitions are the same or differ to this is something that we really need to think about. And it's something I explore in my foundation course. So if you want to learn more about that, please come along to my foundation course, join the waiting list. But this is not an easy thing to do. This is quite challenging. I've been doing this a long time and I still find it very challenging. So if you're a beginner, don't worry. It is difficult, but it is something that gets easier over time. So there we go. So there is some overlap between the definition of a hazard and this, but there is still some conceptual gaps that we need to be mindful of, conceptual pitfalls. So this is saying an event or condition which existed before the intermediate cause. So we've got this other definition, this other term called an intermediate cause. Let's give it. No, let's not use purple. Let's use blue. So we've got an intermediate cause. We've got an event or a condition. We've got something called an organizational factor. We've got some temporal information so that it existed before the immediate cause and directly resulted in its occurrence. So there's some direct causality involved in that. So, these things are close in time and space. Then we've got an indirectly caused or contributed to the proximate cause, so in time and space, and subsequent undesired outcome. So you could say that in the context of STAMP, the undesired outcome is the loss, the ultimate loss that we're talking about. And that loss is preceded by a system state or set of conditions in combination with the worst case environmental conditions where things will lead to a loss. So we're in terms of the definition of a STAMP hazard, we're much closer to the undesired outcome than we perhaps are when we're talking about all of these events, conditions, immediate causes, proximate causes, indirect and direct causes, and organizational factors. So this is a much more sort of complicated definition, but it lends itself to thinking about things through the lens of fault tree analysis or event tree analysis, for example, and they are failure focused methods. So arguably this sort of definition almost forces you to think about things through the lens of trying to find failures that led to a loss, as opposed to when we're thinking about things through the lens of STAMP, what has gone wrong, what failures do we need to think about, but also what went right, what dangerous successes conspired to result in this loss. And this, I mean, this is accident causality, concepts all been mixed together. It's a complex topic, so I'm not going to labour it too much, but just be aware that this is, quite complex. And when we're thinking about things through the lens of stamp, there is a bit of a bridge we have to build between this mindset and how we think about accident causation in stamp. And it's not if you're a safety engineer that has been doing this many, many years, or an accident investigator that's been doing this many, many years, there is a bit of a bridge to cross, and it can be harder the longer you've been doing it this more traditional way. But we can work on that together, and I can answer any questions you have about it. So let's keep moving along then. So these root causes are derived from considerate review. So this is an activity from considerate review of the summation of all the previously discussed. So we've got, let's just mark that again, sorry. So we've got proximate, intermediate, and organizational and observational causes and factors. While the technical concerns are rooted in data and analysis, the organizational factors and observations are often generated from interviews, documentation, meeting attendance, minutes reviews, listening to meetings recordings and group discussions. Responses from interviews will have inherent bias opinion with responses. However, when these observations are taken as a whole, they describe and inform the cultural environment that contributed to the CFT anomalies. Okay, so while the below root causes are specifically separated to clarify the rationale for each, it is nearly impossible to consider one without the others. So that's fantastic. Okay, what I'm going to do is I'm just going to take a slight detour and talk a little bit more about STAMP, STPA and CAST and how we think about causes in the context of unsafe control actions. So these elements, so if this controller provides this control action with a particular context and that leads to a loss or leads to an accident, then that is by definition an unsafe control action. But when we're doing an accident investigation, we are doing it with the benefit of hindsight, and we are focusing our investigation on the specific unsafe control actions that contributed to the accident we're investigating. Now, when we're doing it through the lens of CAST, and because we have the benefit of hindsight, it is wholly inappropriate to refer to those control actions that led to the loss as unsafe control actions, because obviously we only know they're unsafe in the aftermath of the accident with hindsight. And at the time the accident occurred, it may be that the controllers that provided those control actions did not know or believe that taking those actions would result in an accident. So it's not appropriate to call those specific control actions unsafe control actions in the aftermath of an accident. And so when we're doing a CAST accident analysis, we refer to those with a different label. We refer to those as contributory control actions. Fundamentally, they are the same control actions if we just focus on the control actions. But when we take a step back and look at the reasons why it made sense for a controller to provide those control actions, it's at that point it becomes apparent that they may have provided those control actions believing it is the safe thing to do. And that's why we use the term contributory control actions. So that's the first thing we focus on. What are the control actions that contribute to these hazards and lead to losses? The second aspect is what are called causal scenarios. And that is essentially a description of a series of things. It could be one thing, it could be many things that contributed to that unsafe control action, that contributory control action. And they're generally considered in four groups if we're talking about STPA. So we've got controller contributions. So what was it about the controller and the controller's behavior that led to those unsafe control actions? If the controller believed that they were supposed to provide a control action under a certain context and they did that and they thought that was safe, but actually in the real system that was unsafe and caused an accident, then of course that is a causal scenario that we need to capture. There may be issues with the feedback or provided to the controller, or with the feedback path itself. So if there is a single sensor, or if there's multiple sensors for redundancy, or maybe there is diverse sensors and those sensors provide inadequate or misleading feedback that contributes to the controller believing something is going on when it's not and providing the unsafe contributory control action. And then there could be issues with the control action's control path. So how the control action from the controller is actually produced and find its way to the control process. So if you imagine driving your car and you spot a pedestrian in the path of your vehicle and you want to press the brake, you might press the brake, but if your braking system doesn't have any hydraulic fluid in it, or the brakes have seized, or they've stuck off, then of course you're not going to be able to stop and you're going to have an accident. But it's not because the controller didn't press the brake, it's because the control path, the way that control action is actually produced and provided to the control process was inadequate. And then the fourth area is the control process itself. So what is it about the control process that has contributed to this accident? And this is where it gets a bit freaky and a bit weird, because there are scenarios that appear when we start thinking about the control process. There are certain causal scenarios that can appear that are not due to failures. They are due to the way the system is designed, due to the physics of the control process and how they interact with the controller above, or even the broader control structure. So when you're doing your STPA analysis, let's just put CAS to one side for a minute, but when you're doing your STPA analysis, this is where it gets really exciting. And I've had the pleasure of being involved in some quite serious oh shit moments, excuse my French, where the analysts, the engineers, and I've been facilitating and working around this loop, and they're starting to explore, well, why would this unsafe control action occur? And they've identified features of the control process in combination with the feedback and the controller and the control path that would lead to a non-failure occurrence of a catastrophic outcome. So I'm sure you can imagine that gets really excited when you start finding those things. And of course, if you can find those things in the design before you built the thing or sent it off flying, then of course that's fantastic, because you've saved loads of money not having to deal with an accident. And of course you can redesign things if you identify these issues early. But of course, if you identify these things when the thing's built and getting ready to go flying, of course that can have some quite serious potential consequences. So it has to be managed very carefully and respectfully. So yeah, fantastic. I've talked about unsafe control actions or contributory control actions if we're talking about an accident cast. So they're fundamentally the same, but they have a different label for specific respectful reasons. And then causal scenarios. And those causal scenarios can be made up of one or more combinations of things to do with this loop. And of course, the other parts of the control structure that can contribute to this loop. And of course, this is just one jigsaw piece. So I'm not highlighting all of the other potential contributors that you could have. So I hope that makes sense. If there's any questions about that, I know I've just banged on quite a lot, but let me just see if there's any questions, and I'll have a quick drink while I'm at it. It's still quite warm in England. It's not quite as baking hot as it was, but it's still quite warm. So I've got Arch McKinley. Great to see you, Arch. Thanks for coming along from St. Louis, Missouri, USA. Fantastic. Looking forward to hearing this. No, that's brilliant, Arch. As I say, if you've got any questions, comments, concerns, commiserations, compliments, or some abuse, you're quite welcome. Just send me a message, or if you want to have a conversation separately, you're welcome to send me a direct message on LinkedIn or send me a message via my website. But welcome. Thank you for coming along. So there we go. So let's, I'm clicking on the wrong screen. There we go. So let's keep going at this then. So NASA created and implemented the contract structure. Boeing built the vehicle. Together, the organizations agreed to fly. There we go. So if we're thinking about things through the lens of a control structure, that NASA created and implemented the contract structure. Pardon me. And of course, the contract structure, sorry, let me just say that again. So NASA created and implemented the contract structure. So you could say, thinking about this jigsaw piece, you could say this is NASA, their control action is on the crew commercial program. They're going to create and implement the contract structure. And so if that contract structure the design, the implied design of the contract structure, when you actually implement that, that will influence quite considerably, absolutely fundamentally considerably, I should say, the control structure model for your design, development, test, qualification, operations, and in-service support and investigation. And so if that's incorrect, or there are some weaknesses or flaws in it, which we've found, we've seen, we've talked about over the last 21 live streams, then of course this is a contributory control action. So we would have to go and look at, well, why would it make sense for NASA to create and implement the contract structure in the way that they did, that contributed to a lot of the issues in this particular case? And of course, what beliefs did they have? And of course, what feedback did they have? Did they have any feedback? Did they design and engineer in feedback about the contract structure and how it's implemented, so that they can identify these issues and do something about it? I would argue that this series of live streams, if the stakeholders at NASA or interested parties were to see these live streams, hopefully that would influence them to say, hey, maybe we should go and do a review of this contract structure through the lens of STAMP and STPA and see how we can make it more robust and safely. And a lot of the things I've said in the live streams would I believe, would significantly help that. And then again, Boeing built the vehicle. So if this is Boeing and their control actions are to build the vehicle, and I'm going to be pedantic, does build the vehicle in this context mean that they are acting only as a system integrator, or are they a designer and developer as well? Are they a tester? Are they a qualifier? And then again, the last part is that together the organization agreed to fly. So this controller would be NASA plus Boeing, and they made a decision to go flying. And of course, in this case, there's questions over that contributory control action. Why would it make sense for them to go flying when a lot of issues were still outstanding or undone? What were their beliefs? What was the decision making? So I'm hoping just for that short description, you're like, oh my God, Simon, this is some, this is almost a revelation. You're trying to tell me that we could use these control loops to identify and tease out all of these systematic issues. Well, the answer is yes. I mean, it takes time to get, really good at it, but, the basics are there. And if you need help and support doing that, or you just want to have a conversation, then just get in touch. Let's have a go. Okay, so root cause number one. NASA's hands-off approach during contract initialization resulted in insufficient systems knowledge and available data to the government for accepting a development vehicle as a service. Yeah, so it wasn't even a full-on, high standard vehicle. It was a development vehicle. So, okay, so if it's hands-off, that means they're not providing that many control actions and they're not necessarily receiving that much feedback. Or they got loads of feedback but didn't really do much with it. Okay, so why would it make sense for them to behave that way? And it goes back to, I think, this contract structure and their resources from what I gather from earlier on in the report. So NASA's adoption of, and the word adoption implies control actions and feedback of some description. And it might also imply the changes to decision making. So what decision? Well, first off, what decisions are NASA going to do under this new Brave New World, under this commercial services agreement contract structure? But also of those decisions, what level of detail are they going to go to, and what level of feedback and information are they going to demand and actually work with, review, consume, should I say. So adoption of a commercial services procurement strategy through the CCP prioritized provider-led development and minimized traditional NASA insight and oversight. This contributed to the creation of the previous intermediate causes and organizational factors that produced insufficient data for NASA to fully understand the system qualification of the spacecraft, Starliner spacecraft. This approach led to gaps in the end-to-end verification, validation, and interface management, ultimately contributing to crew and mission risk. In accordance with the SAA and guiding documentation, what is the SAA? I can't remember. Just bear with me a second while I dig out the accident report. I normally have it open, ready to go, but I've obviously forgotten to do it this time. There we go. Let's search for SAA. There we go. Space Act Agreements, everybody. There we go. Let's copy and paste that into here. Space Act Agreements. I use this little grey box because it's easier to see. So let's put that down there and zoom in. Space Act Agreements. There we go. Space Act Agreements. Let's put it there. Right, so in accordance with the Space Act Agreements and guiding documentation, NASA teams were prohibited from providing feedback during key design phases or requiring closure on feedback submitted. That's a bit ridiculous, that. So that I think it's kind of becoming really obvious now that if this is NASA and they're providing feedback to the program during key design phases or requiring closure on feedback submitted, and they're not getting that, clearly that is obviously a contributor to this inadequate control and unsafe control actions. Interesting. NASA engineering identified the lack of encompassing flight envelope for reaction control system thrusters in the preliminary design review timeframe. So that was very early, I should say. There we go. Yellow is, I'm marking yellow for time related, chronological information, but we're unable to work to the resolution at the time. Okay, so supporting summary from the STAR report, critical designs were set prior to CCT cap. Oh God, I can't remember what that is. Let's try that one. CCT cap, everybody. Oh, there it is. All on the same page. How helpful is that? So crew commercial transportation capability. There we go. Stretch that out. There we go. Critical designs were set prior to crew commercial transportation capability with limited government interaction. This resulted in NASA being unable to provide critical comments and feedback prior to key design milestones, such as to hardware acquisition. Thus, NASA engineering was prohibited from providing comments to provider, which may have constituted as an unfair advantage prior to contract finalization. This resulted in NASA, there we go. Where is it? This resulted in a disconnect in the system engineering process. There we go. So that that is really serious. As the hardware was already purchased, rendering any potential NASA comments as moot. I mean, I've been in that situation many times over the years, and to be quite frank, that's one of the reasons why I've sort of focused all of my time on trying to bring STAMP, STPA, and CAST out of academia into the mainstream. because that disconnect in the system engineering process, if you have that, in any program, you're going to end up with some serious costly issues in the future, if not serious accidents and losses. It is all about that process and how it's executed. And if it's not controlled and executed properly, then we shouldn't be surprised when we start having expensive nightmares and headaches and accidents. And I firmly believe, and this is my vision for the future, my vision is that STAMP will become core to all of these organizations developing complex technologies and systems. And it will form part of the core of the system engineering process. Because for me personally, yes, STAMP, STPA, and CAST is focused on safety, and STPA SEC is focused on security and cybersecurity. But my personal view, my vision for the future is this becomes core to the systems engineering process, because it is really a safety guided or security guided design method. It's an engineering method. It helps to facilitate the engineers and the stakeholders to identify wanted and unwanted behavior of our systems, and then set clear requirements for that, clear behavioral requirements, structural requirements, that we can then test and audit in the future. And then, of course, if we do have any mishaps or accidents, we can go back and explore the control structure for those systems and identify the contributory control actions, and then do something about it. So yeah, this is I would say that STAMP solves this fundamental problem from an engineering perspective, but it so happens it also helps to solve the organizational aspects and dimensions and human factors aspects and dimensions as well. Okay, so as the hardware was already purchased, rendering any potential NASA comments as moot. Also, NASA staffing plans post-award were not tailored for each specific provider's schedule and culture, with limited dedicated teams for each provider. At the beginning of CCT CAP, which is Commercial Crew Transportation Capability, the focus was on SpaceX, human spaceflight design maturity, with a preconceived notion, that's interesting, preconceived notion that Boeing was more experienced in human spaceflight. So when we're talking about beliefs and decisions, the decision was to focus on SpaceX, human spaceflight design maturity, and the beliefs were that Boeing was more experienced in human spaceflight. So it was all right. It was fine to do that. I'm just wondering what, you're watching this again. I wonder what your thoughts are. What's going on in your minds? Please tell me, comment. Is this making sense? Is this too close to the truth? So the recommendation for development vehicles, as opposed to in-service vehicles, the provider and NASA must partner in the development and qualification plan of known troublesome systems during the design phase. Make this contractually required. Yeah, I think that's fantastic. But again, you might have a troublesome system and just not realize it until it's too late. So I'd suggest embedding, STAMP STPA into the process for any of those systems, because ultimately it reduces risk as well. It's not just, if you use these methods, you're finding what you would already find using traditional methods. So you gain confidence in your existing traditional safety analysis, but you're also finding all of your needed, wanted requirements, and also the unwanted, unneeded behavior, and setting requirements for that. So you get, both sides of the same coin if you use STAMP and STPA. For transportation vehicles, this consideration may include propulsion, parachutes, heat shields, and HSI. So is that human systems integration, I wonder? I don't know. I don't know what that is. Let's try, see if it works. HSI, heat shields and HSI. No, it's not described. That's handy. Yeah, I would include software controllers, certainly. Ejection systems, navigation systems, timing systems, network systems. I think, well, communications, if I've not already said it. Emergency systems, power, electrical power generation. For orbiting vehicles, okay. So they separate out transportation vehicles versus orbiting vehicles. This consideration may include life support, MMOD, so that's micrometeorite, something. There we go, micrometeoroid, orbital debris. So there we go, that's important. What is it? MMOD, there we go, everybody. Etc. Now, just to make a fine point on it. So let's imagine we have a situation. We're doing an STPA. We've got this propulsion controller, trajectory control system, and it provides or does not provide a control action when a specific context it's effectively needed. And so we're wondering, well, we've identified this unsafe control action. Let's look at, well, what are the causal scenarios? What are the contributions to this unsafe control action? We could take micrometeoroid orbital debris as an example. So if, what does the control path look like? What's the design look like? What is the layout of the control path? Where is it physically located? What actuators are involved? And if we get a micrometeoroid orbital debris impact, how is that going to undermine this control path? And then the same for the controller. If there's a micrometeoroid impact on a particular part of the physical controller, let's say it smashes the memory core that is related to controller beliefs or the area where decision making occurs, or have we got two computers or quadruplex computers? How is that going to work? And then, of course, the feedback path. How might MMOD affect the feedback path, the sensors? Could it blind the sensors? Could it lead to the sensors indicating a certain state to the controller so that it believes some things happen and it makes a decision, and that leads to an unsafe control action or not? And of course, what about the control process? So if you get micrometeoroids hitting some of the valves or the pressure vessels or something like that, how could that affect things? So there's plenty of things to think about. Okay, so while appropriate initial areas should be identified at contract initiation, there should also be flexibility to add additional areas as warranted during system development. Yeah, that's what I'm suggesting. And I would argue if you were to use STAMP and STPA, that would help you to identify those additional areas that need to be looked at, and then you could use those methods to look at those in more detail. NASA has had many lessons learned across multiple spacecraft types. The goal of this recommendation is to rebalance the known risk acceptance in commercial services contract type through increased investment in known problematic systems and to appropriately address unforeseen challenges as they arise. Yeah, fantastic. Okay, let's just have a quick drink and have a look, see if there's any other questions in the chat. So just bear with me. Oh, I'm getting the right sweat on. It's so hot. Right then, root cause number 2. Boeing employed inadequate systems engineering and integration in the design phase. So if they're not already doing STPA, do STPA. I recommend it. I'm aware that there are areas in Boeing that are using STPA quite extensively and quite successfully. You know who you are if you're watching. Great work. Keep it up. But really, this program would really help, would get huge benefit from these approaches. And I'm hoping as you watch these live streams, you're like, oh my God, there's so many opportunities here to make this, really make some really, really powerful improvements and make things much better and robust and cheaper, faster, and everything else. Boeing did not adequately apply, which resulted in operating Starliner Propulsion's system hardware outside of qualification. Boeing did not adequately apply systems engineering and integration processes, procedures, or resources to verify all operational environments, lifecycle phases, and use cases. So that's quite a damning statement, to be honest. That is basically, you're not doing the basics right, so why would it make sense for the organization to do that? Because I don't imagine everyone comes to work to do a bad job. I imagine there's lots of very, very professional, very skilled, experienced engineers and leaders working together to do some fantastic things. So what is it about the control structure? What is it about the controllers and how they interact that contributed to this? Let's look further than what's just in this report. This resulted in insufficient certification, Delta certification for new environments as they evolved in the design and development phase of the systems engineering process. Example, helium soft goods. The NTO, nitrogen tetroxide, if I remember that correctly, exposure resulting in leaks. Service module reaction control system, heat, mechanical demand, contributing factors resulted in reduced thrust. Command module reaction control system, corrosion caused by reuse environment resulting in a failed jet. Supporting data from interviews and with key personnel and Boeing's enterprise root cause corrective action review. I mean, I'd love to know what that's all about and how far they've gone with that, because I honestly could really, really help supercharge that with these methods, with these skills. And I think there's some more discussion later on about this, but I don't know if there's much publicly available about that due to the sensitive nature. But I'm hoping if you're involved in that, or you know somebody who is, please forward these live streams to them, especially this one, with the hope that they can see some opportunity and have a go at doing this. In Boeing's design and acquisition of hardware phase, there was overemphasis on heritage, design, and the successful qualification and use of that hardware in different applications. During this phase, the integrated system constraints, operational mission environments for all phases of flight, and ground processing were not well understood. The subcontracted deliverables were then insufficient to perform the independent verification and validation of the Starliner specific use case. So why would it make sense for them to do that? I'm sure there's some really fantastic, brilliant reasons why they did it that way. But if that was incorrect, if there were some issues with that, why didn't the control structure act to deal with that appropriately? Did it act and deal with it, or try and deal with it, and it just wasn't adequate, or what was actually going on? Okay, let's keep going. So you've got 2 more pages, everybody, on this topic. Boeing initially acquired hardware at risk. A lot of organizations do it. It seems like a good idea at the time. Honestly, the project managers love to do this, and most of the time, I'm sure it's perfectly fine because they're willing to take the risk. But if they get to a point where the project managers are like, yeah, let's take the risk, let's do this one-time hardware lot, let's procure these one-time hardware lots early during the design phase. And if it gets to the point in the future where actually they are not appropriate, or the design architecture needs to change due to later safety analysis, whatever, then there should not be, or there should be efforts to combat sunk cost fallacy. So this is where certain leaders will believe, oh, well, we've spent all this money, we've got to do it now. We can't, we've spent the money, we've got these things, we've got to use them. Especially if the safety analysis is saying, no, that's not a good idea. That's a high risk solution. So there has to be some, conversations about that and how to address that. And I've seen that many times on many complex projects, and it's not an easy problem to solve. And I'd argue it's probably 6 of one and half a dozen of the other. But there should always be the openness to be able to challenge those procurement decisions and live with the consequences, because ultimately it is taking a risk. And if you are called out for taking that risk and you don't win on this occasion, we shouldn't let bad losers, if that's not really an appropriate term, but you know what I mean. If you've got the project management organisation that are forcing a technical architecture because they've spent the money, that's really not appropriate. We should be smarter than that. We should be careful with that kind of stuff. Okay. Without specified sustaining arrangements with suppliers, and I mean, this is ridiculous. Wrong colour, this colour. Without specified sustaining arrangements with suppliers and subcontractors. Again, this is a common issue across many programs, but this could be dealt with by having appropriate contracts in place and having open contracts, open consideration and respect about how suppliers and subcontractors need to make a profit. Because it's all right, the big prime contractor basically telling all of these suppliers and subcontractors, we want to buy this, and we need support and sustainment support in the future, but we're not going to pay for that. That's extra cost, and we can negotiate that later. Well, how is a supplier subcontractor, especially the small ones with cash flow and everything else to think about, how are they supposed to contract with this huge organization that's got almost limitless money? How are they supposed to operate in that environment? So this is where the tension between commercial agreements and contracts and business necessity can actually undermine safety. Because of course the supplier subcontractor is probably going to have to make their bid proposal for a sustainment arrangement in the future what appears to be very expensive to cover that level of risk and uncertainty. And of course those in the supply chain, those in the procurement area, they hold a lot of power. They are very powerful and can potentially undermine safety quite catastrophically. And I've seen that a few times over the many years. So that again, the safety management function needs to get involved in those kind of conversations, I believe. What do you think? Do you think that's an element where safety management should get involved? What's your experience? Comment below. This results in a shortage of spares, influencing testing availability and replacements to mitigate in-flight anomalies through post-certification missions. There we go. So the procurement controller has a direct impact on safety in the future. So why would it make sense for them to behave that way? There's loads of reasons, but maybe they should be getting feedback about safety and control actions from above, from the safety leadership, from the engineering leadership, to say, hey, we don't want the procurement behaving that way because it's undermining the safety and success and cost of our program. Yes, they might be making decisions and taking actions that saves procurement some money, but by extension, it's costing the program so much more. There's a famous saying. I'll try and recite it if I can. It's something along the lines of an empire was lost due to a horse's a horse losing a horseshoe because of a was it a pin or a nail? An empire was lost because of a nail. So if you think about the supply chain and the people involved in fitting horseshoes and making sure they're fitted properly, so that the horse riders, the cavalry, can do what they do, and if they're not able to do what they do and they lose a battle, that can lead to losing a war. So this is what we're talking about here, and I maybe should look up where that saying comes from. I can't remember now. If you know, please comment below. While using subcontractors with proven hardware is an acceptable strategy, inadequate integration resulted unknown risk acceptance and effectively underbidding the contract. There we go. Look, am I a mind reader or what? There you go. Underbidding the contract. So the suppliers don't really know what to bid, the commercial team basically stops them making a bid that's reasonable. So they load the bid as much as they can to manage that risk, and then the bid doesn't get accepted. So you're sort of left in a no man's land. And ultimately, these stakeholders should be working together. But more than that, these stakeholders should understand each other. If you know, if you're involved in procurement for a huge organization, your mental model, your beliefs, and your decision making should be based on understanding of who or what your supplier is and what the supplier challenges are. And the supplier should be open and willing to say, look, big multi-billion defense company, as a supplier, these are the challenges that we've got. These, maybe not talk about the margins in too much detail, but talk about the principles of it. This is why our bid is like this. Maybe, and this is something I'm learning myself at the moment, how to write bids and how to not overbid or underbid. It's not easy, and you need to get feedback. And of course, you need to hopefully get feedback without upsetting too many people. But of course, without that feedback, you don't know where your aim, whether your aim is true or not. And so I think it's important to have that feedback and respectful relationship and help each other to stay in business and do good things. We're all here to help each other at the end of the day. Or that's my sort of mission, if you like. My mission and my vision. Okay, recommendation number 55. Boeing provide evidence to demonstrate all Starliner subsystems have been re-evaluated for qualification due to missing operational environments during development initial design phase. I would go further than that, because this says provide evidence about re-evaluation for qualification. It's not about whether they've been re-evaluated, it's what the result of that re-evaluation is. Are there new requirements? Are there change requirements? Is the architecture nonsense? Does the architecture need to change? I mean, there's not enough technical detail in this report to really say, but if we did a control structure, did a STPA analysis of the design, I'm pretty sure within a matter of hours, we could figure out whether that design was appropriate or not. And I say within a matter of hours, I'm not saying that's what a beginner could do. I'm talking about an experienced practitioner and a facilitator with a team of appropriate SMEs could figure that out in a matter of hours or days. I certainly could contribute to that. Okay, so there we go. Refer to ERCCA 2.0, define and develop functions, corrective actions. So is this a different part of the table of contents? Is it this one here, Appendix H? That's one page summary of the Boeing RCCA stuff. Where is it? Is this it? No, I don't think this is. This is the PIT team. Oh no, this is it. That's the STAR Senior Review Panel. That's the STAR summary. Hang on a second. Let's get this right. Why is the show toolbars? There we go. That's what I wanted. Right, so we want table of contents. And it was Appendix E. Sorry, Appendix H on page 311. So if you go to 311. See, I don't understand that. How can this document have 311 pages, but it's got page 312? Anyway. Appendix I. So this... Oh. So that must be Appendix H then. So it's blacked out. Fantastic. Awesome. Just what we wanted. Oh, dear. Why does this look different to that investigation report? Why does this only go up to 280? Oh, it's because it's down there, look. That's why. I'm not even looking in the right place, am I? There we go. There we go. So that's Appendix H. So that's missing then. So this is the ERCCA. Appendix H, Boeing RCCA summary. And it's blanked out. That's really helpful. I can understand why it's blanked out, but okay. Re-review documented risks, anomalies to see if the rationale still holds. I don't think it will. I think that's wishful thinking. In fact, if I was a betting man, 10 American pounds, it won't hold at all because we've had an incident, an accident. You know, and this is one of the things, whenever you have an incident or accident in whatever it is you're dealing with, it is a sign that the control structure is inadequate in some shape or form. And it could be that it's just one place, one controller, one control action that has contributed to this near miss or accident. But most likely there are issues not just with that controller, but with other elements in the control structure, whether it's the structure itself, the interactions between stakeholders, between controllers, or other controller behaviors, or the architecture itself. And so, you know, they've had some risks and anomalies, and I'd argue the rationale does not hold. It's the control structure is inadequate no matter which way you look at it. You need to go and understand what the control structure is, why it's inadequate, and what needs to change to make it adequate in the future. Review other hardware or system being used outside of test qualification baseline requirements. Yes, I think that's a good idea. Go and look at where else things have been used outside of test qualification baseline requirements, and make sure they're not. Recover that situation. So that will be an extra requirement there, an extra recommendation. Evaluate assembly acceptance testing, servicing and maintainability, and manage any associated risks. Yeah, okay. I mean, there is a balance there between the risks to human beings from those activities versus if those activities are inadequate, what risks does that present to the program or to the to space flight, to the crew? In turn, crew commercial programs should evaluate. See, I don't know why this is talking about CCP when this recommendation is for Boeing. Why is that? That seems a bit strange, a bit inappropriate. Because then that should be a CCP recommendation. In turn, CCP should evaluate all deviations, waivers, variances, and directives to determine if the acceptance criteria is still valid. Yeah, I mean, that is a huge recommendation. There's potentially a lot of work involved in that, like a massive load of work. A huge audit trail to look at. Okay, recommendations related to the test qualification are captured in 481 testing section of this report. Right, where's 481, everybody? In fact, let's move this stuff up here a bit so it's a bit closer. There we go. Right, where's 481? Section 46, 47, 481, testing. There we go. Right, so it was recommendations related to test qualification are captured in 481. So let's just highlight that. 481 testing of the report. For programs and vehicles in development phases, plan, contract, robust test campaigns, flight and or ground, with requirements and deliverables, including associated models and criteria for determining success of a test. Oh my God, this is a long sentence. For programs and vehicles in development phases, so that's the context. Plan, contract, robust test campaigns. So is that the action there, recommendation there? So I want you to plan and I want you to contract for robust test campaigns with requirements and deliverables, including associated models and criteria for determining success of a test, substantiated by accredited and rigorous analysis. I think that's what it's saying, plan and contract for those things with all of this. Verify that data available from the test will allow clear determination of pass-fail for objectives and performing diagnostics on unexpected conditions anomalies. So again, that's a lot of work, a lot of challenge, which, to be fair, they should already have been doing that stuff in the first place. So if it's clear that they haven't been doing it adequately, because otherwise we probably wouldn't be in the situation we are. So of course that recommendation needs to be made. There is no substitute for test. Flight tests and integrated ground tests are ideal for understanding whole system interactions. Campaigns of multiple flight tests may not fit a given program's objectives. Wherever possible, the associated models and criteria for determining success criteria of flight tests should be substantiated by accredited rigorous analysis based in ground test. I mean, I recognise this bit, totally get that, but depending on the type of program and the complexity of the system and the design and everything else, the operations, and how that operation is going to take place with other stakeholders, such as the ISS, then, if they need a campaign of multiple flight tests, then that's what they're going to need. I know we're trying to do it faster, cheaper, but sometimes we have to do what we've got to do. We can't just bullshit ourselves that we're not going to do it because reasons. Let's do the hard stuff we need to do. Let's not shy away from it because it's hard. Like John F. Kennedy said about going to the moon, we do these things not because they are easy, but because they are hard. That's if I've paraphrased properly. Comment below, let me know. You probably know this quote off by heart. Fantastic quote. Root cause number 3, NASA's crew commercial program has a culture based on top-level objective for the 2 selected providers to be successful. This heavily influences risk-based technical decisions, emphasizing risk acceptance that supports flight rationale over additional investigation, with a goal of verifying proximate cause and less likely causes. This approach leads to an increase in accepted risk. Yeah, I completely agree with that. Yeah, fantastic. But this bit here about how they do additional investigations and verify proximate cause and less likely causes, I would strongly, strongly, strongly recommend using STAMP and CAST to support that. And I'm hoping from all of the work I've done in these live streams, it demonstrates to you, there is some life in that. There is some benefit to doing that. So please, please do that. I recommend it so highly. Any pressure to be successful with 2 providers that inappropriately influences acceptance of elevated risk erodes trust regarding technical rigor between NASA and Boeing, inside of NASA CCP, and between CCP and their support organizations. Many within the CCP community see this. So CCP community, NASA, Boeing, NASA CCP, and between CCP and their support organizations. Many within the CCP community see this. Pressure when met with pushback regarding the contractor going away or pulling out as rationale for not engaging in difficult conversation topics. Yeah, I mean this is all about trust and respect. If you cannot trust your contractor, and the contractor cannot trust these, the prime contractor stakeholders above them, then this is where, this is how this breakdown contributes to accidents. There should be efforts, a function in the control structure should be refereeing and facilitating these painful, difficult, horrible conversations. And it should be from a basis of mutual respect and understanding and recognition that we don't know what we don't know. We have to be open, we have to be vulnerable, so that these conversations can happen. It is fundamental that these difficult conversations happen. And if there is a chilling effect, if there's an implication for free speech, free conversation, of course, that is going to undermine safety. It's just a matter of time. It is inevitable. For any success, we have to be open and have open conversations. We can't be, don't want to be derogatory, but we can't be soft with this. We have to be open and vulnerable and respectful. That should be part of the safety culture. Having difficult conversations because they need to be had in a way that is respectful and supportive. Now, obviously, in the previous sections, that's not what leadership have been doing in this particular case study. So that's, another issue that needs to be addressed. How leadership engage and set the direction and the culture, what they tolerate, what they stand by and let happen instead of addressing. This reluctance to challenge Boeing's interpretations and failure to act on engineering concerns has contributed to risk acceptance and a fragile partnership dynamic. Yeah, that. From a leadership perspective, if the leadership are getting indications there's a fragile partnership dynamic, they should be making decisions and taking actions. And if they're not getting the feedback, why are they not getting the feedback? Is it because there's something that the controller is doing, the leadership is doing, that's stopping this feedback? Or is it middle management? I've had this a few times. You'll have senior leadership who are like, please, everybody, we need to do this well. We need to do it safely. I want to hear what the problems are, how bad they are, warts and all. Let's have the conversation. I'd rather have the conversation than a smoking hole in the ground and bereave families. We don't want that. And then you've got middle management in some organisations, not all organisations. I don't want to sound too bad, but there are certain people that get promoted to middle management that really should not be there. And especially when you've got organisations that have periods of redundancies over time, certain types of people with certain behaviours and backgrounds, they essentially bubble up to the top and become leaders due to all of the best people leaving due to redundancies and going and finding better jobs elsewhere because they're employable. And effectively the unemployable stick around, and then they arise to a level of power in the organisation where they're more interested in keeping power than they are actually doing a good job. And maybe they don't even realise they're doing a bad job. Maybe they just think that's how it is. But in my experience, they're often incompetent. And when other people that are more competent come along, they feel threatened by it. And especially if there's a toxic situation, a difficult situation in a programme, where a new safety engineer, safety manager comes along and finds issues that everyone knows about prior to that safety engineer, safety manager arriving, and they rock up and start lifting stones and looking at things to try and understand what the hell have they let themselves in for. They find issues, report that to their local line management, functional line management, and then they basically squelch it. They stop it. So if the frontline safety manager is trying to request resources to help them solve safety problems, and that layer of leadership is basically not allowing that feedback up into the senior organisation. So the senior leader wants this stuff to happen, but the middle management are effectively stopping it. Then how do people resolve that? And that's why it's fundamental to have, as part of your safety management system, an anomalous. I can't speak today. Anomalous. Anomalous? No, anonymous. I can't speak today. Anonymous feedback path, and also a more robust feedback path to senior leadership of the organisation and the programme, so they can report these issues, and those issues can be dealt with and respected at the senior level. Because without that independent feedback path, leadership have no idea the kind of problems, the landmines that have been covered up by middle management for various reasons. I'm not saying everybody's bad. I'm just saying in my experience, I've worked with quite a few shockers over the years. Anyway, here we go. While this specific root cause is specific, while this root cause is specific to the history of the anomalies seen on the crewed flight test, several of those interviewed as part of this investigation denoted no change in this culture post crewed flight test. And again, I'm not surprised, because change is difficult, and if something so serious has happened, the organization, the people within it are going to be very, very upset, challenged, defensive perhaps. And so it's going to be difficult to change in the aftermath of that. And that's why it should be a recommendation for a formal change program to move people along this cultural level of maturity. And if there are people in the organization, or if the organization is structured in a way that undermines this, then that has got to change. We can't get it. We can't just change the jigsaw pieces. It means we might have to change the jigsaw, the jigsaw puzzle we're trying to solve. We change the structure. There are several hypothesized reasons for this distinctive culture in crew commercial program, though none can be fully concluded as the singular source. And I wouldn't expect there to be. Humans and organizations of humans are very complex, with lots of intended and unintended feedback paths, lots of perceptions, beliefs, people trying to manipulate things, people trying to do the right thing, people getting frustrated and shutting down. All of those dynamics are going on. We're humans at the end of the day, trying to operate in a complex system. And of course, stress and burnout is certainly a factor, absolutely a factor in these kind of high stakes situations. Ensuring a second provider to ISS is available for redundancy and cost trades has a higher than outwardly communicated priority. Ensuring a second. So we've got SpaceX and then we've got Boeing. Is that what it's saying? Is available for redundancy and cost trades as a higher than outwardly communicated priority. Any instance or issue seen as a failure of the provider could reflect poorly on CCP and or NASA. There we go. So this is about saving face and egos and all of that good stuff. This kind of saving face and egotistical kind of nonsense is something that needs to be recognized and worked through. And I recommend I think I recommended Jocko Willink the other day. Jocko Willink and Leif Babin wrote some fantastic books about how to take extreme ownership and address this kind of behavior. So I certainly recommend looking at that. There's also a few books about Stoic philosophy by Ryan Holiday that I'd recommend. One of those is Courage. Another is The Obstacle is the Way. And there's a third one called The Ego is the Enemy, which is a fantastic book. I recommend reading that as well. But that, when we start to recognize that that's what's going on, those kind of behaviors need to be reflected and dealt with appropriately. We shouldn't have leaders behaving like this. We have to manage that carefully. And I'm not saying it's easy, because it's really hard. Pressure from NASA agency level at headquarters to ensure the success of Boeing. Yeah, okay. I mean, that pressure might have undermined it, actually. Withdraw of commercial provider or not accepting a development vehicle for its initially contracted service is seen as a failure of the program. Well, it is. It is a failure of the program. It is a failure of the control structure and the controllers within it to adequately run a program. That's fundamentally that's what it is. So why is it the program was managed the way it was? Why is it the program had those failures? We need to address those. We need to work on those, and then share that experience. Because this is not the first time we're developing a complex. This is not the first time we've got mega scale commercial programs trying to develop complex systems. We should be learning about how we engineer our organizations, our contracts, you know, how we make sure our leaders work in an appropriate way, how we manage some of these human biases, you know, to do with ego and saving faces and the politics of it. You know, we should be open to addressing those things head on. And then when there is any pushback in the media from people who have never been involved in this kind of stuff, there should be a leader at the top that basically says, no, this is a complex program. This is how we do complex systems engineering. You know, we're not making matchsticks here or bricks. I mean, maybe bricks is a bad example because obviously bricks are involved in the construction of buildings, and if you don't make the bricks properly, your buildings are going to collapse. But let's pick on matchsticks. You know, we're not building matchsticks here. We're building complex systems, and that should be respected, the art and science behind doing that. You know, we should be doing it professionally. We should be doing it with the best science and engineering and social science minds that we've got. Okay, so recommendations for cultural changes and rebuilding trust are captured in the culture and decision-making process section of this report. Yes, they are. We saw those the other day on Livestream 20, I think it was. Additionally, recommendations regarding the path to returned crew flight on Starliner and the overall objectives for Starliner in the future will help to serve to baseline expectations going forward. Yes. We have to accept it's been a painful experience, but we are going to learn from it, and we're going to learn as much as possible. You know, we're going to hold our hands up, and we are going to put our egos to one side, and we're going to go forward courageously into the future and address these issues and rebuild this trust amongst ourselves, amongst the team, amongst the stakeholders, and fundamentally for the crew that are going to fly these things. So this is a blessing in disguise. Yes, it's a painful blessing, but let's not squander the opportunity to learn as much as we can and actually make the necessary painful changes so that we can go forward into the stars in the future. Right, so that is the end of section 6, root causes. I think it's a reasonable summary of what's in the report above. But again, I can't help but think that the causes that have been identified and the recommendations that have been made are a bit broad, a bit generic. You know, these are the same kind of causes you could probably copy and paste from previous investigations because nothing's really improved or changed, arguably, in this context. And so, of course, I'm going to recommend using STAMP, STPA or CAS, depending on the context. But with those tools, you could go so much further with all of this into a lot of detail and make some really, really specific recommendations for change. And then, of course, once those changes, you know, once we're thinking about, well, how are we going to implement these changes, use the concept of a control structure to help facilitate those ideas and those solutions. And I'm not saying it's easy because it's really not. Okay, so we've got to section 7, additional observations, and we've got 5 pages to go through that. And I'm just looking at the clock, and it's 19:21 local. And I'm thinking we could probably leave it there and pick up section 7 at the next live stream on Friday evening, same time, 1800 UTC +1. So yeah, let's just see if there's any questions and comments in the chat. Let's just have a look. So we've got Archibald says, sorry, had another meeting to get to. Keep up the good work. Enjoyed and provoked to investigate more based on your presentation. Thanks. Fantastic, Archie. That's really all I wanted. Is to spark that interest for people to go and have a look and learn a bit more and then have a go themselves. And if they need some help or support from me, just send me a message. Let's have a conversation and see how we can go forward. Even if it's just answering some basic questions. You know, I'm here to serve. That's my sort of mission. And of course, my vision is that this becomes mainstream for everybody and we can avoid having these kind of accidents and wasting billions so we can spend those billions on other interesting things. But fantastic. Let's just see if there's anyone on live stream at YouTube giving me any abuse. Or Facebook? No, that's good. Everyone's been friendly. That's good. Well, anyway, thank you so much for watching. I really appreciate your attention. And I will see you on Friday for the next live stream. Take care.